Hi guys, this is Web3 Boy and welcome back to the channel once again. And today is a new day and we will be doing fallout of Open Zeppelin's problem. And let's just start the video. So what I've done is I have this Joplin app and I basically I create everything like general review of the code and like how do we get from first step to the second step to the third step to the fourth step, right? So this is fallout and let me just show you what it is asking. So they're saying that claim the ownership of the contract below to complete this level, right? Things that might help will be Solidity Remix IDE. So here I have opened Remix IDE in another tab, and this is Ethernot's fallout problem. So one thing I want you guys to keep focus on is like they have this, the name of the level is fallout, right? But when you see here, they have written FAL and then 1 and then out, right? So the spelling of the fallout is wrong. But let's see how we can exploit this code and how we can gain the ownership of the code. So going on further, what we'll do is we'll just the first step is we'll do the general review of the code. So let's just do it. So what I'll do is I'll just copy everything from here and I'll just copy it in Remix IDE. So you guys, it is easy for you guys to understand, right? So this is it. And before doing the general review of the code, I want you guys to focus something here. When you hover your cursor over here, it says not found Open Zeppelin contracts, right? So it is basically not able to, when you see here it says not found Open Zeppelin's contract. So it is unable to import the library of SafeMath. So this one is an older version, right? So it might have happened that Open Zeppelin has moved their SafeMath library from some folder to some other folder, right? So what I have done is I'll just go to the second point before doing the general review of the code, and I'll switch over here, and I have written that click here to know how to import SafeMath correctly. When you click here, I have attached this SafeMath. There was this problem over Stack Overflow and somebody has answered it correctly, and I'll just copy this correct import path and I'll just paste it in Solidity Remix ID, right? So here it is. I'll just remove this line and I guess it's complete now. It's compiled successfully, and here is the code. So we have completed this second point, importing the libraries correctly, and now we'll be moving on the first part, that is general review of the code, right? So let's just see what is happening over here. So first thing is this importing of not importing but adding the license for Solidity, right? And second is this one, Pragma Solidity 0.6.0. That means any Solidity compiler greater than 0.6.0 will be able to compile this code, right? But the problem is, I've already told you do not have to use caret when you are doing it, or when you are deploying it, right, on the mainnet. But for the testing purpose it is correct, but not for the mainnet purpose, right? So the third line says it is basically importing the SafeMath library from Open Zeppelin's contract, right? We have done it, and here is the contract. So the contract is fallout. And the first line, they are saying they are importing the SafeMath for uint256, basically the library over here. They are just using it, right? And here they are basically using this is basically a mapping, right? So mapping of addresses, all the addresses to the amount of uint. All the addresses are mapped to a uint amount. That means whatever they are using in allocations mapping, we'll see it later. So here is allocations mapping, and you'll see that this one is the address of the owner, and this this uint is basically the message.value, right? And the third one is function fallout public payable. So this is basically, it is written that it is a constructor function, but as you all know that the constructor function is, it is a special function that is basically written as a constructor function, but not as this function. But I've done some I have looked over some other videos and over the internet search for some things, and found out that before Solidity 0.6.0 there was no constructor function, but the first function that was the very first function after all the state variables was basically the constructor function, right? So this is the constructor function that will execute only once while deploying the contract, and it says owner is equal to message.sender. That means whoever is deploying this contract is going to be the owner of the contract, right? If it is a constructor function, right? So, and here is the mapping allocations, and owner is mapped to, addresses are mapped to the value that they are providing, right? And modifier I have already discussed in the last video, so I'm not going to discuss it once again. It's the same thing that only owner can this is the whoever is the owner of the contract. Whosoever is deploying the contract is going to be the owner of the contract, and this is a special modifier that any function whoever is using this modifier will be the owner of the contract. And if it is not called by this special modifier, it will revert back that caller is not the owner, right? And the rest of the code will basically execute afterwards it. Now let's move on to the next line. The next line is function allocate public payable allocations of message.sender allocation message.sender.add message.value. This means basically this is a function that is allocate, and what it is doing is it is giving a certain amount of ETH, and that ETH will be added to the allocations mapping, and that will be mapped to the allocations mapping, right? And let's move on to the next one, function send allocation and address payable allocator. So it is taking an input. It's basically taking an allocator that is of address type, and in the require function it is in the require statement it is saying that whatever the allocator is providing, and that message.value, that amount must be greater than 0, that ETH amount must be greater than 0, right? Let's move on to the next one. The next function is function collect allocations and public only owner message.sender. So this is basically a withdraw function, and here the modifier is used, and this modifier basically will be called by the owner only, right? So this withdraw function can be called by only owner. No one else can call this function. So whoever has the ownership of the contract can collect all the allocations, right? So this is basically saying that address this dot balance is basically saying whatever the balance of this contract must be transferred to this message.sender, and this message.sender is owner, right? And if you want to check allocator's balance, here you can just input the address and it will return the balance of the allocator, right? So this is basically the general walkthrough of the code, and let's see how we can exploit it. So it will just get a new instance of it, and let's just get the new instance of it, and then we'll discuss a little further. And one thing I want you guys to notice is, I don't know if you guys have already noticed or not, but the name of the contract is fallout, but the name of the function is FAL1out. That means there is this spelling mistake, right? We will come back on it later, but before that, let's just move on to our third point. And we have covered the constructor function, we have covered the importing libraries, general review of the code has been done. Let's go to the third point, that is the great Rubik's exploit. And here it is. You can read it on your own, but what I want you guys to notice is how it has been done. So there is this line, let me just show you. Okay, here it is. I'll just show you what the Rubik's exploit was. So there were these guys who were running this Ponzi scheme, and it was basically, a pyramid scheme, right? So the name of the contract, the original name of the contract was Dynamic Pyramid, right? So they have named the original contract name as Dynamic Pyramid. That means the contract's constructor function should also have been named as the Dynamic Pyramid, right? But the developer renamed it to Rubik's. I mean, later on they have decided that they will change the name of the contract to Rubik's, not the Dynamic Pyramid. So they did it, right? So they named their contract's name as Rubik's, right? But they did not change their constructor function's name, right? So what happened is, initially before Solidity's 0.6.0's version, before that, what happened was, like, the name of the contract should match, the name of the constructor function should match the name of the contract, right? And if that was not the case, what will happen? The constructor function will not behave as the constructor function, right? So what happened was, let me show you. Here the name of the contract is Fallout. So the function that should behave as constructor function should also have to be Fallout, right? But there is this the Fallout is misspelled as not L but 1, so it is basically FAL1 out, right? So let's just, everything that is the bug of the code is lying right here on your face, right? So let's just let me just tell you more about Rubik's exploit, right? So what they are saying is, they have renamed the contract's name from Dynamic Pyramid to Rubik's in the last moment, but in the process they forgot to update the constructor name, turning it into a public function. So what happened is, they did not change it, right? So if we do not change the constructor function name just as the contract name, this will basically be used as the public function, and since it is a public function, anyone can call it, right? You, me, anyone in this world who anyone who is using this, who is basically contacting this smart contract, will be able to call this function, constructor function. And since you are calling this constructor function, you will be the owner of the contract, right? Just because of this second line that says owner is equal to message.sender, right? So the exploit lies right here. What we'll do is, we'll just deploy this function. Let me just show you. So according to this, if you are deploying the function, right, let's just deploy it, and while deploying the contract, the constructor function will run once, and let me just show you. Okay, here it is, constructor function, and then let me just show you who is the owner of the function. So owner of the function is this 0 address, right? But what will happen when I'll click on this Fallout function, basically what will happen, since I am this particular address is the owner, like this particular address is calling the Fallout function, right? This function. So I will be the owner of the function. So what I'll do is, I'll just call out this Fallout function, and you will see that the owner of the contract will be changing from this 0 address to the address of this particular guy who is basically the same as my MetaMask address, right? So let's just, okay, this has been done. I am waiting for the transaction to be mined in the blockchain, and once it is done, you will be able to see. that I am the owner of the contract, right? So it is confirmed on here, and when I click on the owner, it is basically showing that I am the owner of the contract. So ownership of the contract has been attained, right? So this is here. Let's go back to the let's go back to the Ethernaut challenge, and let me just show you when I will do await contract dot. Let's just see what's the address of the contract, right? This is the address of the contract. Await contract dot owner. So who is the owner of the contract? So it will say that this 0 address is the owner of the contract. So I'll do await player. So I'm the player, the contract address is this, right? So if I am able to convert the 0 address, the contract's owner address to my address, then I have the ownership of the contract. And I have already shown you in the Ethereum remix ID that if I call out the fallout function, I'll be the owner of the contract, right? So I'll do the same. I'll just go on here on the console and I'll do await contract dot fal1 out, and when when I'll call this, this will basically trigger a transaction on the MetaMask pop-up and on the blockchain, and I'll just confirm it. And when it is confirmed, I'll just confirm it, and before that I'll show you who is the owner still. So the owner is 0, this 0 address, and till the transaction has been mined on the blockchain, this 0 address is the owner. But since it is confirmed, the owner will be, I guess, I am the owner of the contract now. See, right now I am the owner of the contract. So the challenge was this only, that claim the ownership of the contract below to complete this level. So I have attained the ownership of the contract. I have achieved this, and what I will do is I'll just submit this instance right now, and let's see if we have completed this or not. I've already told you how this is one of the parallel instance. We'll just submit it into the main instance, and this level will be completed, right? So let's just wait for it. If this is completed, then I guess we have completed this level. Just waiting for this transaction to be mined on the blockchain. Just, I guess, on the testnet it takes a little bit of time, and also use Sepolia, not that other one, right? Okay, so well done, you have completed this level. So congratulations, hurrah guys, and give yourself a pat on your back just because you have completed this level. And this is it, guys. This is all about this level 3 of the contract. And I'll see you in the next video. If you guys have liked this video, if this video was anyhow helpful to you guys, please like and subscribe to my channel, and I'll be doing this continuously over the next 20 or 30 days, and I'll be doing every challenge of the Open Zeppelin, right? So I'll see you in the next video. Until then, bye bye guys.